Welcome to The Explainer. Today we're unpacking what is literally a trillion-dollar battle. I'm talking about the high-stakes race for the future of self-driving cars. Specifically, the massive, kind of ideological war between Tesla and Waymo. The scene right now is just incredibly dynamic. We recently saw Tesla launch its long-awaited Robotaxi service in Austin. Super ambitious tech relying entirely on vision. And on the flip side, you have Waymo, the established commercial heavyweight that's already operating fully driverless fleets for hundreds of thousands of riders across multiple cities. The stakes here? Well, they aren't just about market dominance. We're talking about human lives and the fundamental way we actually design artificial intelligence. To really get this battle, you have to understand the fundamental, almost tribal divide in how these companies view the technology. Take a look at this quote from Elon Musk. He says, "Humans drive with eyes and biological neural nets. Humans drive without shooting lasers out of their eyes." I mean, that perfectly frames the debate, right? Do we build robots that mimic human biology using just cameras and raw brain power? Or do we build superhuman machines armed with heavy sensors and lasers that see the world in ways we literally can't? So, here's our roadmap for this explainer. 1. The robotaxi tech race. 2. The great sensor debate. 3. HD maps versus vision only. 4. The shift to end-to-end AI. 5. Are they actually converging? And finally, 6. Safety, scale, and survival. Let's get right into it. Part 1. The robotaxi tech race. Part 2. The great sensor debate. Okay, just look at the stark structural contrast here. It's night and day. On one side, you've got Waymo's massive, highly redundant hardware array. They are running 29 cameras, 5 LiDARs bouncing lasers around to measure depth, plus 6 imaging radars and external audio receivers. Waymo fuses all of this varied data together using their 4D net system to get this hyper-accurate 3D picture of the world. Then, on the other side, Tesla's ultra-minimalist approach. It's just an 8-camera, vision-only setup feeding directly into a neural network. That's it. It's exactly like human eyes feeding into a brain. No radar, no LiDAR. Now here's the financial reality driving this whole debate, and honestly, the numbers are staggering. Waymo's complex sensor suite, that's estimated to cost around $12,700 per vehicle. Meanwhile, Tesla's highly scalable camera-only setup is just about $400. To put that in perspective, you can immediately see why Tesla is betting so heavily on vision. I mean, if they can actually solve self-driving with cheap cameras, they could deploy millions of autonomous cars practically overnight. It's a huge strategic gamble. Moving on to part 3, HD maps versus vision only. Because, seeing the world is really only half the battle. How do they actually know where they are? Well, Waymo goes in and maps out specific cities ahead of time, creating these centimeter-accurate 3D HD LiDAR maps. Basically, they know exactly where every curb and stop sign is before the car even turns on. Tesla, though, uses a zero map, generalized approach. It's designed to navigate purely based on what it sees in real time, even on a totally unfamiliar route. And how Tesla pulls this off is absolutely fascinating. They use what are called occupancy networks. Basically, their AI takes raw 2D camera pixels and maps them out into a 3D volumetric grid. Think of it like a world made entirely out of Minecraft blocks. Even if the AI doesn't know exactly what a weird object on the road is, say some random debris that fell off a truck, those Minecraft blocks tell it that something is occupying that space. Engineers call this avoiding ontology cracks. The car doesn't need to know the name of the object to know it shouldn't crash into it. Part 4. The shift to end-to-end AI. Over 300,000. No way around it, that is a massive number. That represents the lines of handwritten, human-coded C++ rules that Tesla completely deleted when they launched full self-driving version 12. They literally scrapped all those manual rules. Stuff like, if the light is red, apply brakes, or turn the wheel exactly 10 degrees. They threw it all out to make way for a single, massive neural network. So the really crucial concept to grasp here is this total shift to end-to-end transformers. Instead of a human programmer trying to write a specific rule for every possible scenario on the road, these deep neural networks just process raw inputs, like the camera video, on one end, and spit out steering, acceleration, and braking actions directly on the other, bypassing handwritten code entirely. And how does it learn to do that? By imitating human driving data. It watches millions of clips of expert human drivers and essentially learns to copy their behavior. It's wild. Now, Waymo counters this with a really fascinating hybrid model. Instead of relying on one massive black box AI, they break it down. Step 1 is a fast-thinking sensor fusion module that instantly calculates the exact geometry of the road, knowing where objects are in milliseconds. Step 2 is a slow-thinking vision language model actually based on Google's Gemini that understands the complex, holistic context of a scene, like, oh, that's a police officer using hand signals to direct traffic. Then, step 3 is the world decoder that outputs the actual driving action via end-to-end training. It's kind of the best of both worlds, right? Deep AI scene understanding backed by rigorous, ultra-fast mathematical geometry.
Part 5. Are they actually converging?
Here's the twist. Despite this intense rivalry and their seemingly opposite philosophies, the underlying AI architectures inside these cars are starting to look surprisingly similar. Both companies are rapidly moving away from traditional hand-coded robotics. They're both fully embracing transformer-based foundation models, and yes, both utilize end-to-end training. Even Waymo's commercial fleet and their new research model, which they call Emma, use the exact same end-to-end training concepts that Tesla champions. When the AI makes a decision, the error signal propagates backward through the whole network so it learns. The main difference, Waymo just prefers to keep a highly modular safety net attached to the whole process rather than relying purely on one single giant algorithm.
And that brings us to part 6, safety, scale, and survival. When we look at the raw data testing these systems in the messy real world, a massive contrast emerges. Tesla has an absolute volume advantage. By running their software in shadow mode on customer cars, they've collected over 50 billion miles of driving data. But keep in mind, that's 2D video that the computer has to actively map into 3D. Waymo, on the other hand, only has about 71 million fully rider-only miles, but their data is native 3D. Their LiDAR gives them absolute, indisputable geometric precision of the physical world around them right out of the gate.
And having that native 3D data helps mitigate some very specific risks. See, with Tesla's monolithic, pure imitation learning approach, if the AI encounters a novel situation it hasn't seen before in its training data, it can make a slight error. Because it's a closed loop, that error can quickly snowball, leading the AI to stray further and further from what it knows until it runs completely off the rails. It's exactly like how early AI models trying to play Mario Kart would slightly miss the center of the track, completely panic, and then just violently veer off Rainbow Road into the abyss. Lacking a modular safety net or native 3D sensors means that mapping 2D to 3D can occasionally just miss crucial spatial context. On the other side of the fence, Waymo has hard, verifiable safety data to back up their complex approach. Compared to human drivers, Waymo has demonstrated an 88% reduction in property damage and an incredible 92% reduction in bodily injury claims. Their heavy redundancy prevents a single blinded camera or a single failed sensor from causing a catastrophic accident. So currently, this hardware-heavy approach is definitely leading the pack in verifiable, real-world reliability. But all of this builds up to what might be the ultimate gamble of our era. It's a concept known as the bitter lesson. This is a famous AI theory which states that general-purpose methods, leveraging massive computation and data, will always eventually outperform systems that are packed with hand-engineered, domain-specific knowledge. Tesla is basically betting their entire company on the bitter lesson. They truly believe that if AI scaling laws hold true, brute force data and massive supercomputers will inevitably conquer Waymo's hand-engineered, sensor-heavy hybrid system. So, I'll leave you with this final, incredibly high-stakes question to ponder. As AI gets smarter but remains prone to snowballing errors in weird edge cases, would you trust your life to the ultimate scale of a monolithic neural network or to the expensive, highly redundant safety net of lasers and radar? The answer to that question won't just decide who wins a trillion-dollar market. It's going to define how humanity actually interacts with artificial intelligence on our physical streets for the rest of this century. Thanks for joining me on this explainer, and keep your eyes on the road ahead.